Hello everyone. Today we are going to discuss the fourth problem of Leetcode Weekly Contest 351, which is robot collisions. So, what is given? A string of robots is given to us, and each robot can move either left or either right. Okay, and we are also given the positions and the health of the robots. Now, what happens is that two robots, one is moving towards left and one is moving towards right, collide. Then, if both have equal health, both got destroyed. If one's health is less than the others, the robot with lesser health gets destroyed, and the robot with more health is reduced by one. Now, at the end, we have to return the number of robots that are remaining and their final health. Okay, so let's look at one of the examples, which is let's take this example 3, 5, 2, 6, 10, 10, 15, 12, and RL. So, which are given 3, 5, 2, 6, and RL 10, 10, 15, 12, 10, 10, 15, 12. So these are positions, these are health, and the directions are nothing but RL. Now, you might observe one thing, that if we arrange the robots in the number line, we have to sort them according to their positions. So let's sort them according to their positions. So first two will come. Let's say this is one tuple. 310R is a tuple. So let's sort them. So 215R will be the first one if we sort them according to their position. 215R. Second one will be 310R. 310R. Third one will be 510L. 510L, and the fourth one will be 612L. Okay. So now if we observe carefully that these two robots 3 and 5 will collide, because 3 is moving towards right and 5 is moving towards left. This is right and this is left. So these two will collide. Now both have equal health. I have already told that if they have equal health, they both will get destroyed. So these two will get destroyed. Now we have these two robots remaining, 215R and 612L. Now both have this is moving towards right again, and this is moving towards left. So this is right and this is left. So, and these two have unequal health, so only the robot which has lesser health will get destroyed. So this will get destroyed, and this value will be decreased by 1. So this will be 40. So our final list of robots will be this one, 14. Now, for solving the problem, there are multiple approaches. Now, which comes to my mind first is that we have to sort them according to their positions. So we can make some array, and at the end, also one more important thing here, the positions may be unsorted. So this is the first thing you have to observe, that we have to sort them according to their positions, and the final data statement in the order they were given in the input. Now, if we just store this triplet or tuple, then at the end we might get 5 first and then 1 at next in the final array, the remaining array. So for that we have to store another string which is index I. Okay, so we have to store these four things, 2, 15R and I. So one is the position, health, direction, and index. Okay, these four things we have to store. Now, for our for the ease of the solution, we are going to store R or L as 0 or 1. So L is lower, so we will store L as 0 and R as 1, and we are going to store them as in vector of array 4. Okay, so this is the first thing we have to do. We have to store them in a vector of array and sort them based on their positions. So that's the thing I have done first here. Let me go through this. I have stored them according to their positions, health, direction. If it is R, then it is 1, or if it is L, then it is 0. That is the first thing we are doing, and we are sorting the array. Now the next approach would be to solve them using stack. But I think stack might be intuitive to someone else, but for me, using set is more intuitive. So how I am solving this? For solving this, I am maintaining a set of live robots. So initially it will store all the n robots. Okay, let's say 1, 2, 3, 4, 5, 6, 7, 8. So these are nothing but the indexes of the sorted robot. So let's say that our first triplet is 1 10 4 left 2 5 3 right, let's say like that. So we are storing these indexes. This will be 1 and this will be 2. Okay, this one is the initial index and our operating index is this 1 and 2. Okay, so uh, so this index is nothing but the index in the sorted array. Okay, so now we are just moving through in this array. Now we will check if this 1 and 2, we will check this 1 and 2 like that two consecutive elements. If the first one is right and the second one is left, what we will do, we will just make another collision array or collision vector we can say, and we will put 1 and 2 here because 1 and 2 will collide in the next move. Now this is right and this is left, so we can jump 2 steps back because this 2 and 3 could never collide because 2 is moving towards left. So we can jump to here. Let's say this is R and this is R, this is L and this is L. Now 3 and 4 will not collide, we will move to 4. Now 4 and 5 will collide, so we will put 4 and 5 here. Okay, now let's say this is R, this is R. Okay, now 4 and 5 collide, 6 7 and 8 will not collide, so our initial collision array is 1 2 4 5. Now when we are moving to this collision array, okay, this collision array, so first in the first operation 1 and 2 will collide. When 1 and 2 will collide, let's say what we can say is that 2 got destroyed, 2 got destroyed. Now 1 is remaining. Okay, yes, yes, 1 is remaining. So we are putting as 1. Now we'll check what is the next alive element. The next alive element is 3. Now 3 sign is also R, so 1 and 3 will not collide, so we are not doing any operation here. Now let's say 3 and 4, sorry 4 and 5. Now let's say this is the second operation. Let's say 5 got destroyed. Now we will check what is the next element of for 4. The next element for 4 is 6. Now 4 and 6 have opposite signs, and 4 is R and 6 is left. So 4 and 6 will collide. Now we will make another array which is new collisions. New collisions, we will put 4 and 6 here. Like that we will solve the problem. Okay. Now there are some edge cases. I will explain them while explaining the solution. So that's the approach here. We are just building one collision array and we will iterate over this collision array and we will make another new collisions array, and at the end we are set collision array equals to new collision array. Now what is the number of iterations? So in each collision we are removing at least one element, so there will be at most n minus 1 number of collisions. So our iteration will be what we can say the cumulative iteration, or it will be at most order of n. Okay, got it. Now let's move on to the solution. Now this is the collision array we are making first. I have explained already. Now here we are doing collision 0 is the left element, the index of the left element, sorry, position of the left element, and R is the position of the right element. LH is the health of the left element, and RH is the health of the right element. Now if LH equals to RH, then we are removing both of them from the live, because if let's say these two 10 and 10, if they collide, both will get destroyed. Now we'll check what is the left element of 10 and what is the right element of 10, is this 10. Okay, what is the left element of L and what is the right element of R? If these two have opposite sign, let's say R and L, and like that R and L, we'll just put them in the new collisions array. You can go through the this part. This part is nothing but some implementation details regarding C++. And if the left one is higher than right one, we'll just remove the right one from the array, decrease the value of left one, and similarly we'll do check that if let's say this one is 12 and this one is 10, this will be 11, and we will check what is the right element of 10. If this is already right, if this is L, then we will put them this pair in the new collisions array. Similarly for the right one, and at the end this part is quite easy. We are just at the end we are just storing the answer. You can go through this, and if you have any doubt regarding this part, you can ask me in the comment section, or any part of the video if you are not understanding. please ask in the comment section. Please like the video and subscribe to the channel.